Can you see my screen?
Yes.
So today we are going to learn about the properties of covalent compounds. Okay. We have studied what are ionic compounds and what are covalent compounds. In covalent compounds, your sharing of electrons will happen. So, as I told you that ionic bonds, they are very strong because they have strong electrostatic forces of attraction between them. That's why they have high melting point. But here, the intermolecular forces between the molecules, they are weak. So that's why your covalent compounds have low melting and boiling point. So this is the one major difference between your ionic compounds and the covalent compounds. High melting and boiling points and low melting and boiling. For example, you can see water, where sharing of electrons will happen between hydrogen and oxygen. It is a covalent compound. It has a melting point of 0 degrees Celsius, which is low, and a boiling point of 100 degrees Celsius, which is also low. Okay, so covalent compounds have low melting point and boiling point. You have to remember. Clear?
Yes.
We'll study more properties. First of all, write down this point. The first difference between ionic compound and covalent compound is that ionic compounds have high melting and boiling point, and covalent compounds have low melting and boiling. Is that clear?
Yeah.
Second property is that covalent compounds, they do not conduct electricity in any state. Okay, covalent compounds, they do not conduct electricity in any state, but we have read that ionic compounds conduct electricity. Okay, ionic compounds conduct electricity in the molten state or in the aqueous state. Okay, so this is another difference. Third point says that most covalent compounds are insoluble in water. Okay, they are insoluble in water. That means they are insoluble in polar solvents. And from ionic compounds, we have read that ionic compounds are soluble in water and not soluble in organic solvents. So here opposite thing happens, that covalent compounds are insoluble in water and they are soluble in organic solvents. For example, iodine. Iodine is a covalent compound. It is a covalent compound, so it is insoluble in water and it is soluble in your organic solvent, that is your ethanol, that is C2H5OH. Okay. So you have to remember these things, that pure water does not conduct electricity because pure water is a covalent compound, and covalent compound do not conduct electricity because there are no ions, free ions to carry the charges. Clear?
Yes.
Write it down first. Next is the shared versus unshared pairs of electrons. So, for example, shared pair, it is a pair of valence electron which is shared between both the atoms, and unshared also means lone pair of electrons which is not shared between the atoms. For example, let us see ammonia, NH3. Okay, so the structure of NH3 is something like this, and you know the electronic configuration of nitrogen, it is 2,5. Okay, so one electron is here, one electron of nitrogen is here, and one electron of nitrogen is here. Hydrogen electron is here, here, and here. That means hydrogen is completing its duplet, okay, by sharing one electron from nitrogen. But still there are two electrons which are left in nitrogen. 1, 2, 3 are involved, but we have to make 5 electrons, right? And one electron, it remains as a lone pair. That means they are unshared pairs of electrons which are not shared between the atoms. And shared pair means which are shared between the atoms. I hope the difference between shared pair and unshared pair is clear.
Yes.
Yes, for example, HCl. So this is the electron of hydrogen and this is the electron of chlorine. So this electron, it is a shared electron because it is shared with the hydrogen atom. Otherwise, these chlorine electrons, they are unshared pair of them. So this one is my shared pair and these are my unshared pair of electrons. Unshared pair of electrons are also known as lone pair of electrons. Cases. Now we'll study the rule of electron diffusion here. that there are some cases in which the electrons around the central atom, they may not have a noble gas configuration. Noble gas configuration means octet of electrons. For example, BF3. It doesn't have a noble gas configuration boron, but still it is stable. So it has 6 electrons around the boron atom. We say that the boron atom is electron deficient. So if you want to name a compound that is electron deficient but still it is stable, it is your BF3. So you can write down boron. Okay, and we have 3 fluorine atoms, 1 and 3. What is the configuration of boron? Atomic number is 5, configuration would be 2, 3. Okay, so that means it have 3 valence electrons, 1, 2 and 3. Okay, so fluorine have 7 valence electrons, 1, 2, 3, 4, 5, 6, 7. So fluorine also completes its octet by sharing 1 electron from boron. 1, 2, 3, 4, 5, 6 and 7. So fluorine is completing its octet by sharing 1 electron from boron. But boron, after sharing 1 electron from each of the fluorine, it doesn't complete its octet. It have only 6 electrons. You can count 1, 2, 3, 4 and 5, 6. So central atom boron, it only has 6 electrons around the boron atom. So we say that the boron atom is electron deficient. Why electron deficient? Because to achieve stability, it should have 8 electrons. Central metal should have 8 electrons in their valence shell. But in BF3, it is stable. Still, it has 6 electrons in its valence shell. So here you can see we have 3 fluorine atoms. 2, 7 is the electronic configuration. Boron atom 2, 3 is the electronic configuration. See the Lewis structure, electron dot structure. After drawing this, you can realize that after sharing electron from fluorine, then also it have only 6 valence electrons in its shell. Okay, and the structure of BF3 is like this, and this structure is known as trigonal planar because it is in the plane. It is in the plane of paper. No bonds are above the plane and no bonds are below the plane. Understood?
Yes.
To draw this. Then we will study electron expanded octet. Example of a compound which has expanded octet, more than 8 electrons in its valence shell.
Hey students! Interested in boosting your studies? Enroll now at Keddy Edtech. We offer online tuition for the Cambridge curriculum, grades 6 to IGCSE, AS, and A-level. Start learning with us today.
Let us see here we have 2 examples. One is of SF6 sulfur hexafluoride and one is your phosphorus chloride, okay, PCl5. So in sulfur hexafluoride, draw the electron dot Lewis structure, So you can see first how to draw the electron dot structure. You have to write down the electronic configuration first. For sulfur, it is 2, 8, 6. So you have to make 6 electrons in its valence shell. CB part, you have to make 6 electrons in the valence shell of sulfur. Then fluorine, it is connected with 6 fluorine. You know the electronic configuration of fluorine. It is 2, 7. So we have 7 electrons in the fluorine atom. So fluorine completed its octet by sharing 1 electron from sulfur. But sulfur, it shares electrons with 6 fluorine atoms. So the outermost electrons become how many? 12. Okay, so sulfur hexafluoride has 12 electrons around the central sulfur atom. So we can say that it is an example of an expanded octet. It should be 8, but here in this case there are 12 electrons. Similarly, phosphorus chloride, after sharing, you can see the structure. After sharing the electrons from chlorine, it has 10 electrons around the central phosphorus atom. So we say that phosphorus has expanded its octet. And the shape is like this, PCl5. For sulfur hexafluoride, it is octahedral. Okay, so draw the electron dot structures of PCl5 and sulfur hexafluoride and see if you can see here that phosphorus atom, it has 10 electrons in its valence shell, and after sharing electrons from fluorine, sulfur has 12 electrons in its outermost shell. So these both are your examples of expanded octet. Sulfur dioxide, SO2. So sulfur atom, it have double bond with each oxygen atom. It keeps the pair of non-bonding electrons, that means unshared pair of electrons on the sulfur atom. There are 10 electrons around the sulfur atom. That means it is also an example of expanded octet. So draw the electron dot structure of sulfur dioxide. Write down the electronic configuration 2, 8, 6. For oxygen, it is 2, 6. So you have to make 6 electrons, 6 valence electrons around sulfur and 6 electrons around oxygen. So oxygen will share its 2 electrons with sulfur to complete its octet, and sulfur it will have to share its 4 electrons with the oxygen. That means 2 shared pair of electrons. And as I already told you that if you have 2 shared pair of electrons, then it is a double bond. 2 shared pair of electrons means that double bond is formed between sulfur and oxygen. So in SO2, the shape is something like this. There is one unshared pair of electron or lone pair. So the shape is bent for SO2, and the electrons you can count like this: 1, 2, 3, 4, 5, and 6. So 6 electrons around sulfur, and oxygen have completed its octet. 2 electrons are there, and 1, 2 shared pair of 2 electrons are there, unshared pair of electrons. Okay.
Okay.
Let me connect my charger. We have read about the ionic bonding, covalent bonding, and the third type of bonding which we'll read in this chapter, chemical bonding, is coordinate bonding, which is also known as dative covalent bonding. So coordinate bond or dative covalent bond, it is formed when one atom, it provides both the electrons. One atom is providing both the electrons which is needed for a covalent bond. So for dative covalent bonding, we need two conditions. Okay, one is that one atom to have a lone pair of electrons. Why? Because these lone pair of electrons it will provide to the second atom. Okay, so one atom to have a lone pair of electrons and the second atom to have an unfilled orbital. Okay, that means it is empty to accept the lone pair. In other words, an electron deficient compound. So in a simple language, here one atom should be electron rich and the other atom should be electron deficient. So that electron rich atom, it will provide both its electrons needed for the covalent bond, and the electron deficient, it will just accept the electron. Okay, so understand the difference between covalent bonding and coordinate covalent bonding. In covalent bonding, both the atoms are sharing their electrons to complete the octet. Okay, but in coordinate covalent bonding, only one atom shares its electrons and other atom just accept it. Okay, write down the definition of coordinate bonding. The best example is this: ammonia. So formation of coordinate bond in ammonium ion, how it does happen. So example here you can see example is the ammonium ion. Ammonium ion is NH4 plus ion. NH4 plus. How NH4 plus is made? When ammonia combines with a hydrogen ion, it forms NH4 plus. That means NH3 reacts with H plus to form NH4 plus. Hydrogen is electron deficient because it only have one electron in its outermost shell, and that is also lost, so it is electron deficient. Now it has space for 2 electrons in its shell because hydrogen wants to complete its duplet. Nitrogen atom in the ammonia molecule has a lone pair of electrons, right? This is my lone pair of electrons. That means it is electron rich and it is electron deficient. So the lone pair on the nitrogen atom, it will provide both electrons for the bond, and we have a formation of a coordinate covalent bond, and it is represented by this arrow. That means nitrogen is giving both its electrons to the hydrogen. So the coordinate covalent bonding, it is represented by this arrow. That means it is giving, and this arrow means it is accepting both the electrons. Is it clear?
Yeah.
So write down the definition of covalent bond, coordinate bonding, which is also known as dative covalent bonding. One example is your formation of ammonium ion from ammonia. Bonding in ammonium ion. Work AlCl3. You have to show the covalent bonding in aluminium chloride. So aluminum chloride, basically the formula of aluminum chloride is AlCl3, which is electron deficient. But at high temperature, what happens? At high temperature, it dimerizes. Sorry, at low temperature, it dimerizes and form two molecules of AlCl3 to form Al2Cl6. Okay, why they combine? Because lone pair of electrons on two of the chlorine atoms, they form coordinate bonds. So you have to make the coordinate bonds of this and show the coordinate covalent bonding in this particular molecule. So take a screenshot of this for your assistance and this. You have to try it at your homework, and if there's any doubt, you can ask me in the next session. Done?
Not yet.
At high temperature, it exists as AlCl3, which is electron deficient. It still needs 2 electrons to complete the outer shell of aluminum atom. At lower temperature, it dimerizes.